Alright, welcome to the 10th video in my character controller tutorial series. This video is going to be all about animation trees. And this is basically what we're going to be building. In the previous one, I just had like a capsule with like some glasses and some hair on it. Actually, he's over here. And we're going to be adding in this 3D model. This 3D model I'm going to link in the description. It's a CC0 public domain. You can use it for free. You don't have to credit me or anything. Just like a free model that you can use for your projects for whatever you want. And yeah, so it has animations and whatnot as well, and we're going to be showing how to set up an animation tree. And right off the bat here, I'm going to kind of give an overview because I think a lot of people will just be able to run with this. So what I kind of wish I would have known when I first started working with this, so it's like kind of like a modular setup like a lot of things in Godot. So here's my model I imported. If you right click, I'll show a little bit more in detail on this a little bit later, but this is a quick overview part for everything that we're going to be doing. So you import your model in, then if you right click make local, it'll be on like the 3D model, so you can make it local. And then inside your model, if it's animated, it's going to have this animation player. And you can set the animations to play in code and whatnot, but you know what an animation tree does is gives you a bit more advanced controls. You set the animation player that the animation tree controls. And yeah, I don't pretend to know like every detail about this, but I think I can give a pretty good overview. So the part of interest right here is the tree root. So if you like kind of reset it, you're going to have a lot of options here, and it kind of looks confusing, but yeah, so you have this tree root and you have a lot of options. It kind of looks confusing, but the two main ones of interest that you are generally going to want to use the animation tree for are the state machine and the blend tree. So yeah, the deal with the state machine and the blend tree, those are kind of like the two controller nodes that allow you to kind of blend and manage different animation states and kind of switch between them in a clean way. So like state machine, you just set up the different states you can be in. So I have like run, walk, crouch, jumping, and then the arrows define how it should transition between the two states. So you can crossfade them. So like here I have it set to crossfade in 0.25 seconds when he's running into the jumping state, so that kind of smoothly blends to his jumping animation. So you see here, you know, when I click jump, it kind of slowly fades, and then if I were to set this crossfade to like 5 seconds and he's running, it's going to go like really slowly to jumping because it took 5 seconds to crossfade. So you can kind of define the different states he's in a state machine. And yeah, that's the deal with state machine. And blend tree is a little bit different. And in a way, it's kind of non-committal which one you choose. So like they each have their own strengths. The state machine they're for different purposes. You might be able to accomplish virtually the same thing as this with a blend tree, but it would be very convoluted. Blend tree can like blend together multiple animations at once. So like say you want the weapon holding animation blended with the run animation. That's the type of thing you do with the blend tree. But you know, say I want that, and okay, darn, I already set it to a state machine node. Well, what you can actually do is copy it, clear it out of here, and then if you add a blend tree, you can paste your previous state machine that you copied into the blend tree, and then you'll have to like swap it in code. Like the animations it is playing, like they have specific so in code you have to set these values. So like blend space 2D kind of allows you to blend between different walking animations, and you have to, if you hover over these parameters in the animation tree, you're going to see that it gives you this property kind of URL or whatever you call that. It gives you like a path, to this property, and you set that in code. So you're gonna have to alter that if you do something like this and move your state machine, but point is, you can kind of nest them in any way you want, and it's not really committal. They're used for different things, and yeah, I could do, so we have a blend tree, and then we have our state machine in that, and then I could add a blend tree inside the state machine, which is inside another blend tree. So like, you can kind of nest them in this kind of modular way, very, very Godot pattern there. So hopefully that makes sense. Yeah. And yeah, hopefully that all makes sense. So usually I think you're going to be choosing like a state machine or a blend tree, but it's very flexible and it's up to you, and it's kind of non-committal. Like you can always, if you make a state machine, then you decide later, okay, you want to nest it inside a blend tree, you can always copy and then paste and then create like a new blend tree as your animation tree root node. Or I guess it's not a node, whatever this is, animation tree root object here. And then you can paste in your state machine to that. Yeah, so it's very flexible, kind of non-committal. And you know, you can end up with a pretty crazy structure of like nested stuff, I'm sure, for a more like advanced animation. The other ones I didn't talk about here, like animation node animation, like this, you can set it as a root node, but like even here, this is an animation node animation. So I have these nested within the state machine. And then you also have your blend spaces, and you can even, like a blend space here, I have my idle animation in the center, so like when we start walking, it slowly transitions to the walking animation. Or you could even be walking like slightly diagonally, and then it kind of does something in between like the strafe animation and the walking forward animation. And then even in here, you could nest a state machine in one of these if you really wanted to. I can't even imagine like what you would use that for, but point is, like, it's a pretty flexible system. So yeah, hopefully that all makes sense. This is kind of like very Godot like modular nested pattern. A little bit, some of it's a little bit confusing. Like, it gets kind of complicated with these parameters. I didn't realize at first, but you hover over it and then you get the property, and then you can set that in your code in the animation tree set, you know, and just like I was scrubbing over the walking animation, you know, you can set this in code based on your character's velocity, blend between different animations as it is appropriate for however they're moving, and that is the animation tree. I think that's like a pretty decent overview. Hopefully that made sense. And yeah, that was kind of like everything I learned. I wish I would have known right off the bat using it. Really quick, the blend tree. I'm not really going to be using it much, but you can use it to kind of compose multiple animations into a unique animation. So like if your character's holding like a weapon in one animation and you want to blend that with like all your running, walking, crouch animations, you can use a blend tree for that. Yeah, so like you can nest state machines and whatnot and other blend trees within it, but like you can add together or subtract animations from each other or blend them together. So like if I add a add to node and connect it to the output of the blend tree, and then add like my running animation or my idle animation with my running animation. I don't have like a weapon holding animation added to this guy yet, so like, you know, you can blend between the two, and do stuff like that, and then you could filter it to only blend, let's say for example like the head bob. So this looks kind of weird, but we have the head bob from the run on the idle animation, or you could do like the head bob from the running with the walking, and it looks kind of strange, or like the crouching as well. That's what the blend tree is for, though. You can combine multiple animations, and it's just kind of another way of composing this tree of animations and getting control over the final output. I think it's mainly, I haven't used it much to be honest, but I think it's mainly used for this. You can see like this, and then like, for instance, if you could also nest like your state machine and then combine the state machine with some other animation. Like if this was the weapon hold animation with like the running, walking state machine we had before, you could see how you could kind of allow him to hold a weapon while also running, this type of thing. All right, so yeah, now I'll go through kind of setting this up from scratch. This is where we left off on the previous tutorial where I implemented the third-person camera mode. You can download this desertdroid.glb model here. Link will be in the description. I'm actually gonna delete all the previous stuff I had in the world model node. I have my model set up with a world model node 3D that I'm using to handle everything like the first person camera is not supposed to see. So everything in this node gets hidden on mine with this bit of code right here. So yeah, I'm gonna put my Desert Droid model into the world model node, and he's actually backwards here. I need some wrong size, so I'm going to make a container node for him. Put him in there. And flip them around, hold control, snap to right angles, or not right angles, but like every 45 degrees or something. And I think 0.703 was a good scale, I remember. And yeah, so once you import a GLB, actually real quick, I'm going to show something in Blender. So yeah, I have this model in Blender. It is rigged up with a Rigify rig, and one important thing, I have the blend.blend file up on my GitHub too if you want that, but one thing to note, it's not going to export right with a Rigify rig into Godot unless you go into data, armature, and then you need to make sure you have export deformation bones and flatten bone hierarchy checked, because Godot is not able to really use the Rigify rig. So this just exports like the deformation bones if you do that on exporting a .glb. And that took me a while to find out, and I think it has the deformation bones, and it just exports these for Godot to use, and it doesn't export like the entire Rigify rig. Okay, yeah, so just something I thought was worth mentioning, because that took me a while to figure out. I was playing with different settings, and those were the two that I needed to check to get the animations to export correctly into Godot. It was like working, but the animations were like subtly off until I checked those two checkboxes. Okay, so you export it into Godot, and then you have this .glb file, and I'm putting this in my world model, and then the GLB itself is like a Godot scene basically, or it like treats it as a Godot scene when you drag it onto your character model like this. So what you can do is right click, make local, and this will like separate all of the different components of the model. So it separates like all the bones and mesh and whatnot. So it's like all within the same scene. And then that exposes this animation player node within the imported .glb. And yeah, as I showed at the start, you can use this to set different animations. And so we are going to add an animation tree to our world model container here. And then when you create an animation tree, you have to first assign the animation player it's going to be controlling, and then you can do all that business with adding the state machine and BlendTree and whatnot. And yeah, for this one, I'm going to be using a state machine, but yeah, as I said, you can convert between the two pretty easily, or like if you make a state machine and then decide you want to add a BlendTree as the root instead, you can copy your state machine and just put it as a node within a BlendTree later. So yeah, so if you add a animation node state machine and assign the animation player, then you can go into the animation tree, and then it's going to give you this layout where you can add different nodes in this animation tree window. So yeah, I already like made it in the beginning part there, so I already know what I want to add. So like there are a few different things you can add here. I mean, you can obviously nest blend trees and state machines within it, but the nodes of interest that you're going to put in your state machine are animations or blend spaces usually. So I know I need a mid-jump animation as one of the states he can be in, and a mid-jump crouch animation. And then, yeah, if you just hit play on this, or like So the state machine at any point is going to be in one of these states or at one of these like kind of nodes, and it can travel between any of them, and then you can assign behavior for how it should act when transitioning between any two nodes here. So it's going to end up looking like a spider web by the end of this. You can try to kind of keep it organized for your own character. It gets a little bit convoluted, but yeah, you can always like nest. You could nest a state machine within a state machine if you wanted. So yeah, you can try to manage complexity in various ways. Okay, yeah, so I know I'm going to need 3 blend space 2Ds, so I'm just going to add 3 of them here. And the 3 blend spaces are going to be run, walk, and crouch. Because I have 3 different walk cycles or 3 different movement cycles for each of these. So so these are all the nodes that I'm going to use. 3 blend spaces and 2 regular animation nodes. And the regular animation nodes are self-explanatory. They just, when the state machine is at that node, or if it's traveled to this particular little box on the grid or the diagram, then it's going to be playing that animation. The blend space is a little bit different. So if we go into the walk blend space, it gives you this grid, and then you can click on the pencil tool here, and then you can add animations at various points on the grid. And so like I'm going to add idle in the center. So this is going to be mapped to like the player's movement speed essentially in the X and Z direction. So like idle is going to be in the center. And then so the positive Y, this is the walk blend space, so I want it to be the walk animation. And then I think you need more than 2 to have it actually start blending, I'm pretty sure. I think, yeah, it's not going to blend without more than 2. So walk is at the top, idle is in the center, and then I'll do walk strafe left on the left, walk strafe right on the right. And I'm adding like points on this grid that are assigned to specific animations. And essentially, so we add walk backwards. Okay, so we have like all of our points on the grid. I'm just going to make sure they're at like the exact right point. -1, 1, 1, and -1. Yep. So essentially you have this little tracker of where exactly the blend space point is at. And like, so it's the closest to the center point, which is assigned to the idle animation. Oh, and he's still on this animation, so it's playing that. But if I go click play on the state machine, so now this is highlighted in the state machine, that means it's playing this animation right now. So then if we go into this animation or into this blend space, the state machine is playing a blend space. And then so within the blend space, as the blend space is currently playing, wherever this little crosshair is, whichever animation it's at, it's going to play that one more. And like, okay, so he's idle right now. I'll blow this up so you can see a little bit better. He's idle right now in the center, but if I start moving it slowly towards the top of it, it's going to start blending towards the walk animation. And if it's halfway, it's kind of like slowly walking. And if it's all the way, then he's doing his full walk animation. And so essentially we're going to like map this to the velocity. So like he's walking, and then with my character there's a little bit of friction when he stops. So he's going to slowly stop walking, and then he's going to be stopped. So it kind of smoothly blends between the animations. So there's no like jitter when it changes between them. And yeah, hopefully that makes sense for the blend space. Basically, you can just smoothly blend between a bunch of different animations instead of like, okay, we just do the dumb way of like, okay, when he's moving right, play the strafe right. When he's moving forward, back. Here you can like kind of smoothly blend in between them, and it looks a bit better. And it also just offers us like a bit more of an easy way to, transition between all these animations and manage all the different animations. So yeah, so that's our walk blend space. I'm going to put him at idle. And then you can imagine what we're going to do for our remaining animations here. Just like we have set up for the walk space here. If I can get this in the center, because I want it to be idle. yeah, we're also going to add pretty much the same thing for the run space as well as the crouch space. I have in this 3D model, so idle again for the running, and then at the top, run, and then run strafe right on the right, run strafe left on the left, run backwards on the bottom, and pretty much the same thing on the crouch one. I'm going to add the, oops, not a BlendTree. I'm going to add the crouch idle animation in the center, crouch walk forward on the top, crouch walk backwards on the bottom, crouch strafe right on the right, crouch strafe left on the left. And I'm just going to double check I did these points at the right spots. And yeah, that's pretty much all you have to do. Let me double check the run blend space. I did it right as well. Looks right. Yep. And then yeah, we got our blend spaces set up for all three of these. All right, and that's really all the nodes you have to add to your state machine. You could just leave it like this, and you can use the travel function to travel to any of these nodes by their name in the state machine within code. You have to first get a reference to the animation node state machine playback, and then you can use the travel function to travel to any of these. And then in code, you also use the set function on the animation tree. If you go look in your scene here, and select the animation tree, you'll see after adding the blend spaces, you're gonna have this parameters drop down. And then like for the blend spaces, this has a property of its own here, the blend position. And like, okay, so it's playing the walk blend space right now. So just like I said, the top part is the walk forward. So if we increase the Y to 1, then it's playing the walk animation. And if we decrease it back down, it's playing the idle animation, which is in the center. Positive X is going to be the strafe right, negative X strafe left. And you use the AnimationTree.set with this parameter name here to set the different animations in code. And yeah, you could just use this how it is. You don't need to create these connections between the states. You can just manually force it to like travel to them and it'll work fine, but I'll show you what that looks like. Okay, yeah, here's an example of a finalized setup without proper blend spaces, and you can see, so it's in the walking animation, then when I sprint, it kind of jumps to the sprint animation, and that's the purpose of the state machine connections. You can set a blend between the walking blend space and the running blend space, because right now it just jumps through the running walking blend space and the crouching one. So it'll like smoothly crouch down, and you can set that with state machine connections. As an example of transitioning between two nodes here, say we're in our running state, and then I'll make a connection to the jump state. And then when you make a connection here, and you have the connection node selected, it's gonna have this crossfade or X-fade time, crossfade, same thing, between from this state to this state, because the arrow is going that way. And you're probably also going to want to remove advanced mode auto and just click it to enabled, because auto is probably going to auto advance to the next state. We don't want it to automatically do that like after it's done a running animation. We want to have us control it in code. I think you can have it to where you play one animation, then the next, and the next, and the next. So like a what do you call it? Having a bunch of animations in order and transition between them automatically once one's done. Well, we're setting that in code, so gonna have to set it to mode enabled rather than auto. I think disabled would prevent any movement between the two states. But we're going to be needing to use the travel function, so we won't have that. But yeah, so if he is running here, boom, he's running, and then if he goes to the jump state, you can even see just clicking the animation state nodes in the state machine, it just jumps there right now. But if you set a fade time of like 2 seconds here, now you see he slowly blends to the jump state. I'm going to set mine to 0.25, and essentially I'm just going to do this for all of the different animations, and I'm going to leave everything else just at the same. I'm just changing it to enabled rather than auto, so it doesn't auto advance, and I'm setting it to 0.25 seconds connection. And basically I'm just gonna make like a spider web here. Same thing back, because like when he's jumping and then he goes back to running, you know, I don't want it to auto advance, and then I want it to be smoothly blended over 0.25 seconds or so. So I'm just gonna really quick do all of these connections here, and let's glitch it out. I'm gonna do all these connections here and connect like all of the different states to all of the other different states, because you can basically go from any of these to any of these, and I want it to always smoothly blend. So that is what I'm gonna set up here very quickly. This to this, I think that's all of them connected to the mid jump. Yep. And then I'm gonna do the same thing for the crouch jump. Boom, 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 boom. And then now I just gotta change all of these green ones to the gray ones and make sure they're not automatically changing animations without me wanting it to. And I wish there was a way to select all these at once. I don't think there's a way to do that though. Set them all to just regular enabled, and I pretty much want all of the transitions to be 2.5 seconds or so. So I'm just gonna run through and like copy paste all of these to be 0.25 seconds. All right, so all of them I've set to just regular enabled, not disabled, and not auto, so it doesn't auto advance between the animations, but we can still travel between them. And I've set the crossfade time to 0.25 seconds. And now when we are on any two animations, it smoothly is going to blend between the two. And like if we go from jumping to walking or jumping to crouching, it's always going to smoothly blend between the two, or running to crouching, it's always going to have a nice smooth blend. So that's pretty much all you need to do in the state machine setup, and you got this nice spider web here. It's very clean and nice and easy to kind of see what's going on, of course. And yeah, and then now we'll go over to the code. All right, and then also I'm going to change the height of my capsule. He is 2.55 meters tall. He's 8 feet tall apparently. And then 2.55 divided by 2. Get my capsule set up so it matches my new character body, character model. All right, and now for like the code portion of it, we're gonna be using this kind of template that we set up in our state machine, and we're gonna be controlling it from code. So we're gonna be using these names, whatever you named your state machine nodes. We're going to use those and reference those in code, and we're also going to reference over here. You got your parameters on your animation tree. These are important to know, like any blend spaces. You can go right click, copy property path, and then you're going to be able to use that in code. So I'm going to go in my code. I'm going to put some stuff right up here above my process function. I'm going to create an update animations function to handle all animation updating. I'm going to put that at the end of my process function there. So I'm going to call this function every process call. And then to kind of start controlling the animation tree from code, we're gonna need to pull it in as a variable first. So var AnimationTree. We can just go drag it in if you didn't know this. Then that will get like a reference to the path of it. So on ready, I'm going to grab a reference to the AnimationTree node. And then I also need one more for our state machine. State machine playback. And this is going to be of type state machine playback, and you can grab this from the animation tree. So I'm going to grab in this reference to the animation tree object here, and you can see right here in the parameters, we have this property parameters playback. You can copy the property path, and you can use the .get function. Yeah, actually it auto completes it here. You can grab the state machine playback node, which is like a special node used for, or special like object used for controlling the state machine. And now that we have these two, we can utilize them in this function being called every frame to basically set up our character to trigger certain animations based on our velocity and if we're jumping or crouching or and whatnot. All right, so a little bit more code to tie everything together here. I'm going to write the update animations function, and this is basically going to just swap in code through the different states of the state machine based on like how the character is moving, if they're crouched, if they're walking, running, things like that, or if they're mid jump. We will set the appropriate state, and I also just realized I gotta connect these, so I'll just redo that. So all of the states are connected, and we will move through them in code. So the first thing I'm going to add here is if the character's not on the ground, basically. So if they're not on the floor, and then I have some special handling for my stair code. So sometimes they can be not on floor, but still like snapping to stairs. So I add a little check here. So if they're not on the floor, or if they're no clipping essentially, then we are going to play one of the two animations, the mid jump crouched or the regular mid jump animation based on if they're crouched or not. And then we'll just return, because if they are not in the air, then I'm going to play one of the walk cycle animations, the run cycle, walk cycle, or crouch walk cycle. So for this, I need to get like the relative velocity. The normal character body 3D velocity is global. So I need it like relative to the characters. Like if they're running forward, I want it to be positive z velocity essentially. So no matter which way they're facing, like I always want it to be relative to the character, not the world. So for that, yeah, I first get the x and z velocity, multiply 1, 0, 1, and the y coordinate 0, multiply that by the velocity to get just the horizontal velocity, divide that by the maximum movement speed of my character, which I have this, returns different values for running, walking, and crouching. So this will be an x and z vector of their horizontal movement should be between 0 and 1, usually. And then I take that and I multiply it by the global basis inverse of the character. So if you watch my Transform 3D video, you'll know about this. If not, I'll try to link it down below, or you can look it up on my channel. It's how Godot's Transform 3D type works. But yeah, essentially, the basis encompasses an operation of rotating something, and you can take the inverse of a basis to unrotate it. So if we do the opposite of the rotation of our character on this global velocity, that will make the global velocity relative to our character, essentially. I hope that makes sense. A little bit confusing, but essentially, yeah, you take the inverse of the global basis of the character, and then the inverse of an object's basis multiplied by a global velocity gives us the velocity rotated relative to our character. Yeah, so, and then I'm just putting it in this relative velocity xz. And then I have this vector 2 that I can use for the blend spaces. So like if he's going to be moving, so for instance for the crouch blend space, I'm just using this animation tree set. And where did I get this? If you go into the animation tree, I hope I named this right, crouch blend space, blend position. Yeah, so you can go copy property path, and then you can paste it into your code if it doesn't autocomplete for you. I'm not sure if this one does, but here I'm directly setting on the animation tree in code, just the same as we were setting when we were playing with the blend spaces over here. Was it not playing? Yeah, just as we can like kind of set the blend space here, and like when it's 0 he'll be idle, and then when it's 1 that means he's walking forward. We're just gonna set these in code essentially. So just like I was doing by hand there, I'm using the player's velocity to set the blend space to the blend position, copy property path, and then it's gonna play the crouch blend space 2D and set the blend position to the relative character velocity here. Hopefully that makes sense. I feel like it's pretty self-explanatory, I guess. And I'm basically just going to do the same thing for all of them. Yeah, but here is the finalized function here. And yeah, so for each of the blend spaces, depending on if we're sprinting, then we go in the run blend space. If we're crouching, we go the crouch blend space, and we're traveling on the state machine to each of the nodes. And yeah, notice like we're just literally referencing their direct names of the state machine nodes on the state machine playback, which we got up here. And then with that, we are all done. And yeah, basically that is the tutorial. Now you have a animation tree set up if you followed everything correctly. You got running, you got strafe running, you got the different walk cycles, and all the animations smoothly blend together, and they smoothly switch. Like when we switch from walking to running, it smoothly switches from standing to crouching, or from jumping to crouch jumping. Got all these various different animations that are smoothly blended between, and hopefully it is clear how you could extend these concepts to any amount of animations. Like if you had a more complex character controller that you wanted to do, you know, hopefully you can see how these concepts would transfer over to, you know, any character controller you want to do, and hopefully you feel empowered to work with the AnimationTree node in Godot now. Yeah, so hopefully you learned something. I hope you got something out of this tutorial. And yeah, rate, comment, subscribe. Let me know what other videos you want to see in the comments. I'm thinking I'm going to build out this character controller some more. I might also do a video on like a weapon system for it as well, because I have some code for that mostly done. I just got to like blast out a video on it. So yeah, thanks for watching, and rate, comment, and subscribe.